Hmm? Something that doesn't change. Doesn't have variable. Any questions from the homework? We need to talk about first one.
No, not. I mean like tonight.
No, we haven't had the lesson yet. Any questions from last night's homework that we discussed? You and your partner could not figure them out. Everyone's absolutely stumped.
Actually, let me check.
Wait. All right.
Oh no, we've done.
What?
We've done this before, but I forgot about it. 6:33. Yeah. Oh. I mean, I think I did it wrong, but because it's too easy, and I don't know. We've done this so many times.
So, what is the probability of getting a 3 when there are these on it? 1/6, right? So, how many times we expect 3 to appear? How do we figure that out?
6 times 100.
A 6 of 100. That's
Oh,
it.
okay, so I got it right.
That's it. Probability is going to continue to cycle back through. So yeah, that we have to round it, right? Because if it's an expected amount of times, round up. Or if it's 1/6, it might round down.
It's 16.66.
Yeah. It's 17.
Yeah, so 17.
It was too easy. They thought I did.
Anything else? All right. This is also why it is critical for us to have partners. As I still see some of us trying to sit rogue, I will start to have individual conversations if I need to with people, because we gotta talk with other people. That's the best way to learn and know what we don't know, is to discuss our ideas with other people. So Jerry and Ken are working on a problem. Now we do have the line on this one, right? The or equals line. So they find the boundary point. Ken made the number line. Jerry noticed the problem. Doesn't the line at the bottom mean it includes that part? So doesn't that mean x equals 1 is also a solution? And Jerry says, well, that would actually look like this, right? Just a dot on the 1. What, if you walk into this conversation, would you tell them to make everything hunky-dory, A-okay, peaches and cream, whatever you want to say? Alex, I don't know. Peachy, people say peachy for good. I don't know why. But.
Well, that your number line is close. All you need to do is just fill in the dot, because x greater than or equal, well, actually less than or equal to 1. So you would just need to fill in the dot.
So what can we say about these number lines compared to what the answer should be?
That they are incorrect.
Yeah, Ian? You combine the two, right? If we're trying to show x is less than 1, and or at the same time x can be equal to 1, we're actually showing both of these graphs on the same graph. So really what we should tell Jerry and Ken is, you're kind of both right, you just need to combine your graphs, right? We need to show x is equal to 1 and it's less than 1, so we fill in that point. So our diagram, we should kind of remember the triangle diagram type from earlier chapters in the Math 7 book where we did like fraction, decimal, percent, yeah, the portion web. So we want to generate 2 missing representations from each inequality to describe these parts. If you can't figure out what the 2 missing are, look at the other ones and see what they're giving you. One's going to be verbal, right? One's going to be graphic, and one is going to be algebraic. The letters, the numbers, that means algebraic. So for A, what do we want to write then? We want to represent it in other ways. Make a graph and write it verbally. So with your partner, okay, you probably only need about 3 minutes. If you're missing, like the 2 pieces that we're missing, make those.
No.
So a couple people came and asked me about graphs for the homework and how specific I wanted it to be. Would we ever make a graph that has the negatives up here and the positives down here? No, right? That's just not how the number line works. So all we need to show is the point at which we reference. So to help you with the first one for just a moment, what's the point that we're referencing? -1.5, just throw that in the middle. Put the circle around it. Ask yourself, open or closed? Open, because it's not included. Shade, left or right? Left, right? Because less than. Another trick? Now, if the variable is the first thing you read, the inequality symbol points the direction you shade. Because it opens to the bigger one. So we would do that. And that's it. That's all. You don't need any other numbers, any other tick marks. That's as quick as your number line can be. Now, if it gave you more instructions, like make a number line showing 5 values, and follow the instructions. But for me, that's all I need. And verbally, how would we write this out verbally? Annie?
Oh, x is less than -1 1/2.
X is less than -1 1/2. Thank you very much. Ava, if you were to write B algebraically, can you tell me the symbols or like what you would write?
Well, since x is greater than or equal to 2, then you have to put x over there, like to the right, because
Point to the right. Then just the 2.
well, no, but you put a line under the
Put the line under there because it's greater than or equal to. And then the graph, it's hard to like talk about them, but we should all have the same thing. I'm hoping because we're accelerated 7 guys, I'm going to move kind of quick today. Reference point is circle shaded or open? Shaded, right or left? Right, greater than. Careful. Ian, what does C read as? Like, how would you say C? How would you read that, say that? Right, I mean,
like, x is equal to 2 or less. No.
So, clean it up.
Wait.
Say it better.
Yeah. 1 sec. Let me think.
You say the inequality first, or equal always comes second. So what is it, greater or less? Less than?
Or equal to 2.
There you go.
Okay.
X is less than or equal to 2. And then that's how we say it. X is less than or equal to 2. Less than. Now, Zin really wanted to do this problem. Like, wanted to do it minutes ago. So now we're going to talk about boundary points and what they really represent in the context of a situation. Anyone ever see a bridge or anywhere where it says, like, max height 11 feet 6 inches or max weight 2 tons? Or so what if your vehicle is 11 feet 6 inches? Like, I don't know. I'm just posing the question. What if my truck weighs 2 tons and the bridge says max weight 2 tons? Does that mean I can go? Or I can't? Like, am I included or am I not included? So, if these signs actually showed me a graph, I would know if I was safe or not, right? Because if I could see, am I in the graph or out of the graph, that would tell me if I'm safe. Exactly. So, here we're talking about speed limit. Right, and funny enough, if you notice, there's also speed minimums. If you drive under a certain speed, you could also get a ticket. Yeah, because it's dangerous. It's just as dangerous.
Like if you drive, if you have
All right, so hold on. With your partner, represent these situations with an inequality. You guys are for a minute, and if you're done with that, move on to 38. But represent these situations with an inequality.
Wait, what did we just work on? 36 or?
Yeah, we were on 36. We're now on 37.
Oh my god.
Wait till C. We did Robert Wablo in here, right? With the hands? Or well, you weren't in here for that. Or we did it the other times, didn't we?
yeah, we were that.
Yeah, sorry. Were you sitting over here yesterday? Maybe I'm just moving. Well, not maybe. Bougainvillea, you interested in doing A? Come do A for me. Naya, you want to do B? You're going to do B after Bougainvillea. Alex, you want to do C? C's a little tougher. It's okay. You're good. Bilal, you have interest in doing C? You don't, not right now. Like Bougainvillea's going to go, then Naya. Yes? No? I can come talk with you about it first if you want.
Okay, you're on the right track. So your height.
Wait, is this the magical world with no taxes?
Yeah.
Okay.
Yeah. Well, it doesn't even matter because money you spend, you spend the tax, or if you don't have tax on anything, you don't spend it. Like food, you don't have to pay tax on like grocery food. So, right is the first thing we're trying to tell everybody. Like, what is it? So it says, you must be 5 people. So think about that second person. You must be 5 people. Could you write it at first? Could you write it at over? Up until you get 8. And you need 7 according to the book. Check. If you stand on the river, check. Read again what it says.
Oh, but less than 7.
So it might help you to first just draw a graph of it showing who's allowed to ride.
Wait, is this like graphs?
Not 2 graphs, 2 points.
Oh,
Because we're referencing it.
It's supposed to be close.
Close.
That's what I was
Right now you're saying 5 is bigger than H, and H is less than 5. Alright, so the question to be asked is the boundary point included or not? On a roadway that has a 65 mile an hour speed limit, can I drive 65?
Yes.
Yes, unless you're Van Halen and then you can't. But you guys probably don't even get that joke. So if you go to write it as an inequality, x can be less than or equal to 65. Assuming there's no minimum speed. Assuming I don't have a minimum speed, I can drive anywhere between 0 and 65. I know, if I'm driving at 0, that's dangerous. But alright, so you're good.
So I don't have to write it down.
No, you don't have to write the verb. The verb was given to us. And this got a little glitchy with the smartboard, but that's your 65. Would the point be included or not? It's closed. It's shaded. So he tried to. It's got a little smartboard glitchy. But so to shade or to graph this, shaded point, graph to the left. Shade to the left. Naya? No, you aren't. Not faster than the speed limit. You can go faster than the slow cars, but not faster than the speed limit. Yeah. Speed limit. Oh! Bougainvillea, we didn't read closely enough. So Bougainvillea gave us a graph, and this is why A was actually harder than B. Bougainvillea gave us a graph of what we're allowed to drive. right? X, we used X as what we're allowed to drive according to Bouvendier. I'm going to now write this as T for ticket. At what speeds will I get a ticket? Who could say how I will get a ticket? Rachel? If speed is greater than 65 or even 65 and a half, I could get a ticket. So I can get a ticket at greater than, T being the speed. If my speed is greater than 65, hold up, bring it back. If I went to graph that, would 65 be shaded? No, not for the ticket graph. Now, Naya's graph for B is absolutely perfectly correct. Because we're talking about how much money can we spend. Can you spend all of your money? Yeah, you may want to, you may not want to. Can you spend less than all of your money? Okay, I think some of you need reminded of that. You don't have to spend all your money. So, we can spend 10 or anything less. Now, I helped help Bilal a little bit, but not very much on this one. C is pretty difficult.
I just can't figure out the
So, you can write above C if you need, just to have some space.
I still don't have the inequality, though.
That's okay. Do the graph. If you can do the graph, I'll do the inequality for you. What's his graph representing? What would the units be that we put below it? Feet, right? Because that's what it's referencing us. I like it. I'm going to modify one little piece. So Bilal is saying the height that we're allowed to be less than 7 was the first thing he shaded. So open 7, point to the left. 5 or more, closed 5, point to the right.
I shouldn't have an arrow because it can't go on.
Ooh, now hold up. We can actually just set that down for a second. If it'll let me. You just combine the two. So when Bilal first started working on this, come on, go away. He said, so do I make 2 graphs? I said, no, not 2 graphs, but you have to reference 2 points. Right? So we know my one reference point, I start there, go up. My other reference point, I can't be there, but I can be below. So if I were making this graph to make my life super easy, your graph was good, but I just don't put in as much work. 5, 7. I'm allowed to have 5. I can't have 7. And then I just shade between. And that's it.
Should I try this column?
Use the 2.
Can I try the inequality? I don't think I have it, but I think I have it at the same time.
I'm confused at how that can even be reality. Alright,
The
I'm
thing
giving it a
is,
shot.
I'm
So
not
the
sure-
algebraic inequality
I'm not sure this way.
is what we call a double inequality.
So right, yes, that's good.
Well, be careful. I haven't looked at it, so I don't guarantee that you're right, but
Oh, he's right.
double inequality. Why is it called a double inequality? Are you following my book?
Is that a 7 or a 1?
That's a 7.
Alright, now,
No, not the 7. But
Alana, what do you think? Because you're drawing in my books, apparently. I'm going to pick on you. So, Alana, do you think this double inequality is correctly showing height for roller coaster?
No, sorry, Bilal.
What do you think needs to change?
The height, it says that it's less.
Yeah, I meant the other way.
It says that
Oh,
7
wait.
is like over something.
Okay, so should I be taller or shorter than 7 to ride the roller
You have to
coaster?
be shorter.
I got to be shorter. So this is showing that h is less than 7. But if I cover up that part, this is showing h is greater than or equal to 5. I agree with all of this, actually, because 5 is less than or equal to h, and h is less than 7. So this is actually correct. I kind of asked it in a tricky way, because I knew that you guys were, I don't know, drawing in the book or doing whatever you were doing. The trick that I saw in a couple people's papers, these always have to be pointing the same direction. If you wrote it like this, that wouldn't be right for this situation, but it could be a right representation of what's going on. If we write this, think about this. 5 is bigger than h, so h is smaller than 5, right? 5 is bigger than h. And then h is smaller than 7. Okay, h is smaller than 5 and h is smaller than 7. Like, okay, yeah, it's kind of redundant, right? Because h is smaller than that and smaller than this. So if we're trying to enclose, a double inequality encloses a shaded region, right? So Bilal's graph was 5 shaded in, shade over to open 7. That represents that. The line tells us to shade it in. 5 is less than the height, and the height is less than 7. Does this make sense? A lot of us were a little iffy as I walked around. Can we check our papers and make sure we have this written right, please? Like, put your eyes on your paper for a moment. Just check it. The camera thing. All right, Ellie's working on a dollhouse.
Wait, can you put that up there?
Yeah, sorry, I gotta throw the smart thing up there. You should be able to. The length of the shortboard is unknown. Well, get a measuring tape or something. Ellie put 3 shortboards end to end, and then added a 12-inch ruler end to end, and the total length was less than the. Well, this is getting complicated. So, since it's complicated, let's draw a picture. All right, pictures make things easy. Take a moment, draw a picture, show how we can just represent what the problem told us. So show how we can represent just what the problem told us. The shortboards are the same size as each other, yes.
Wait.
What?
So, I think I got the length of
Just don't build a dollhouse.
Wait, the rulers are each end, right?
Search it up.
So right up against each other, she added her 12-inch ruler. What she has is a ruler.
Oh, one?
Right, not a measuring tape. So she has boards that are 2 different lengths. One board is 54 inches. The other one she doesn't know. Ellie put 3 short boards end to end. 1 board, 2 boards, 3 boards. Right, here's our 3 boards. Sorry that they have end points. They just do. And a 12-inch ruler. So then we could say, all right, this we know is 12 inches. Right, so we could say this is 12. Now, if we don't know what the boards are, what could we say for their lengths?
Wait.
X or B or something. Then added her 12-inch ruler. Just touching the end. End to end means ends touch ends. Like, so we have board length, and board length, right? That we don't know.
End connects to end. The end of your pencil connects to the end of mine. No, we're trying to figure out the length of this one.
Oh, yeah, okay, that part.
That is so perfect.
What do we know about the total length? It's less than right? If we say the total length is L or something, less than 54.
Wait, can we just say 3b plus 12 is less than 54?
Ah, so we actually know what the total length is, and kind of algebraically we can represent this. Because we could say I've got a B, and a B, and a B, and a 12, and that is less than 54. So, B plus B plus B would be 3B plus 12 is less than 54. Now, how do we start to solve this? If this, and you can think for a moment. I had a math teacher who said, like, let's step into a momentary existence, or I forget exactly how he would talk about it, but he's like, we know we're going to break the rules, but we're going to step over here for a minute, then we'll come back into, like, where we need to be. If this was equal, and this was an equation, we just start doing things to both sides, right? We can do that in an equation the exact same way, except like I cautioned you yesterday, be careful with multiplication and division, we'll get there. What would I do first here? Will?
You would first subtract.
Subtract.
12 for both.
Yeah.
For both of them.
Take the 12 inches off of both sides. We know what that is, so remove it. So if I take 12 inches off of what was less than 54, it's now going to be less than 48. And now we only have 3 boards. Zen? Yeah. Cut it down so you can look at only 1 board. So we divide by 3 on both sides after I throw things.
Wait,
What?
isn't it 40?
Oh,
Yeah, isn't it 42?
I'm
Yeah.
just writing what people told me.
Yeah, be like, what? How did you get
Yeah, I was super confused.
Somebody said 48.
I was like, did I do something wrong?
You guys should be here when I do it to my Math 2 class, because they're really, really, like, hard to find mistakes, because the math is really complicated. So we get, like, 4 steps later, and then they're like, oh, wait! And we have to go all the way back up. And, I mean, we would have gotten to the division that was really complicated to do. Actually, 48 actually does work divided by 3, so you maybe would have never caught that mistake, because it would have still worked out easy, but B is now less than
14.
14 inches, right? We want to label. No naked numbers.
Wait, wouldn't it be B?
She was working at inches, I think. Unless her dollhouse is big. 14-foot boards. You ever tried to move like a big piece of lumber? It's really weird. Has anyone ever watched Tool Time? Or the Tim the Tool Man Taylor?
Oh, so technically.
Kind of too old for you. There were always these scenes where they'd have like a long board and they'd turn
Oh, and
and
then
like
hit
smack
somebody.
somebody in the face.
Wait, so technically we don't know what B is.
We don't know what B is, but we know what B is restricted to. So we might as well show this. Now, how many reference points do we have here?
1. What?
Ooh, you said 2. Why?
Because it's on either, like, it doesn't equal one thing. Like, B is not 14, so we have to have B, right? What?
So 14 is a reference point, right? Can we agree with that?
What?
Lana?
I think we would put B there because B is like part of the equation.
So B is going to be what we shade, right? So B is our shaded region. Can B be 14? No, so it stays open. We shade left. Alex?
It would have to stop at 1 because you can't have negative length. And if
We have to stop at 1?
Zero.
Stop at 0. Yo, yeah, 0. Alex is the one who got us there. If we stop at 0, now this is one of those mathematical arguments. Can my board be a length of 0?
No.
Not if it exists. right? If it exists, if it is a board, it has to have a length. But if you want to argue like the theoretical side of things, could it be 0? Is 0 less than 14? Yes, 0 is less than 14. Could it have a length of 0? Yes, I have a board of 0 length right here. Right? I have no length. But if we're working with a physical situation, 0 would not be shaded because we have the boards. So it's somewhere between 0 and 14. It can't be 0, can't be 14. Questions? No preguntas?
Apparently not for the film.
All right, Jordan, Terry, and Morgan. Let's go visit some more of our friends. You guys don't fly kites anymore? You kids do that?
I used to fly them.
If you go to the beach, you can fly a kite real easily.
Yeah.
Oh, yeah. All right, so check it out. Let's look at our info. You guys are essentially just going to solve this on your own. I'm going to try not to help you much. Jordan, Terry, and Morgan are going to have a kite flying contest. Jordan and Terry each have 1 roll of kite string. They also each have 45 yards of extra string. Morgan has 3 rolls of kite string and 10 extra yards of string. All of the rolls are the same, and the girls want to see who can fly their kite the highest.
Wait.
So hold on. Since you start poking holes in it before you even know all the info. Since Jordan and Terry have fewer rolls of string, they decide to tie their string together so the kite can fly higher. So write at least 2 expressions to show how much kite string Jordan and Terry have. So do that, then we'll move on. Okay? Yeah. They each have a roll.
What?
Each of them each have 1 roll. You have a roll, I have a roll. And then they each have extra.
Okay, that makes a lot more sense. So Morgan is
Well, Morgan has 3 rolls and 10 yards.
No, Izzy, right? It says Jordan and Terry each have 1 roll.
Morgan isn't part of that.
It's just those.
Yeah, this is Jordan and Terry. And they have 45 yards extra.
Wait, so the 45
All right, let's break this down. I think I'm going to get one of those big, like, Jordan has a roll and 45 yards. Terry has a roll and 45 yards extra.
Oh, okay. I get that.
Morgan has 3 rolls and only 10 yards extra.
And they're all.
Now, Jordan and Terry, to take on Morgan, combine forces and tie their stuff together. We're living in a reality where knots don't take up any string, and we still have the full length of string, even once we attach them.
So 2R plus 45 is something.
Do it. You can keep moving on in your book. Once you get A, move on to B. So keep looking at the problems in the book. It might give you more information.
And then we can do the Megan Morgan that morning, and we can like subtract ours and stuff.
Okay, so you minus 2 R's.
Alright, for those of you who are getting annoyed because you haven't looked any further, in C, it then asks us, how long do we need to make a roll in order for Jordan and Terry's kite to fly higher? So that's really what we're looking at.
So we need to know R.
Well, then we can figure out what R could be.
How? We simplified it down. At least I think we simplified
We have about 3 minutes, so we should come back together.
I don't know.
How do we express... No, it's cool when I get it in my back pocket. I've only done that like twice. How do we express what Jordan and Terry had together? Mia? Yep.
Oh, 2x plus 9.
Well, yeah, in my situation up here, 2r plus 90, but they said x, so I'll use x, I guess. Like the problem told you use x. I change my variables depending on the problem. I don't like my page to be full of x's. 2r plus 90, right? Or 2x or whatever. Then if theirs is gonna fly higher, it's greater than...
Oh, so that's how we can simplify.
And that is how we can start.
Yeah, we did that. We got that.
Totally did that, right? So,
Oh, you might want to take 3 R.
easy. Oh, thanks. I was gonna write on top of it. Easiest option. Actually, I'm going to take you a harder way to show you an example of why you got to be careful. Hold on. Why you got to be careful with division. So, just watch me. You don't even need to be doing any of this. Just watch me. Now, for a minute, you're going to be like, you're taking away that doesn't make sense, but that's okay. I'm going to delete or subtract 3x from both sides. That stop. This is like my music people, right? Stop. Negative x. It's okay. Okay? Since my x's are over here now, I'm going to get rid of my constants from over here. Okay, now I know this is terribly, horribly ugly. Calm down. I did this for a reason. If you solve this out the way that makes sense and the way that we like, we would have probably ended up with 80 greater than x, right? Or x is less than 80. But I did this to show you. How could I turn x into a, or negative x into a positive x? Can't, because I don't want to add x's over here.
Oh, isn't it if you have 2 negatives on both sides, you can just make it positive?
So if I multiply by -1, right, the opposite of x, right, that's going to make x. I multiply by -1. I get 80. What happens to my inequality? Should x be more
No, it
than
flips. It flips.
when you do opposites? Either division by opposites, work with me. When we either do division involving opposites or multiplication involving opposites, it does the opposite to everything. This flips.
Wait, was I still right? No, I was still right.
X would need to be less than 80 for Terry and Jordan's string to be long.
Did you do that whole strategy just to teach us that it's like...
Well, we're going to do more of that here coming up. But that's, because I keep saying like, oh, just be careful with multiplication and division. The only time you have to be cautious is when it involves negatives.
Because the easier way is like...
Yeah, take it. So, my advice really is try to keep your variables positive. Life will be better that way. That's all we got. Have a great day, guys.
Thank you.
Thank you. Cheers, cheers. Un buen día.